Hi there, welcome back. So today I'm going to show you how to calculate basin average precipitation. So in the last tutorial, right, the part 2, we already have seen how to download that analysis data. So I have this data already downloaded. So now I have to even calculate the basin average precipitation for each of this sub basin or sub watershed, right? So that is our goal, and let me count that. I think we have 13 sub watershed. So I have to prepare that shape files. I'll extract that shape file. I already mentioned that one, right? The previous version of HEC-HMS doesn't, right, have that, but this latest version we can even export that shape file because we created this shape file from DEM. So we have to use this shape file to calculate basin average precipitation. So how can I export this shape file to our arc map? So that's the option. Go to GIS. If you go there, you can export layer, which one you want. You can export that sub basin, and you can even export other layer as well. Okay, so if I want to export that, so I'll export as shape file. So you can see that shape file. I'm selecting the location where I want to save it. Okay, I have the predefined layers there inside shape files, and if I just export it as a sub basin, let me just quickly export that. I have the previous one, so it will be replaced. So I'm giving the name sub basin. Okay, sub basin 01, and I'm saving that. If I finish it, it will be there. So at the same time, if I open my GIS, that one, okay, because we are working continuously on GIS, and we can display everything on GIS, and we can even change our view to arc HEC-HMS at the same time, right? So what I'm going to do right now, I'll import that because I need to have that shape file for my calculation. Okay, I'll use R script, R programming language, or maybe familiar with that one. I have written this script maybe more than 2.5 years ago. So yeah, later on I have also a script on Python, but I'll use that one that I written in R programming language. So here it is. If I just zoom out a little bit, then yeah, so we need to have that basin because we have to even count the name, because the names are not right in sequential order because we submerged, we merged some of them. That's why the names are not in sequential order. The highest number of sub basin now is 17. However, we have only 13 of sub basin, so we have to even remember the name, right, which one is which. Then we can create our basin average precipitation based on the same name. Then we can even connect those. Otherwise, if we just follow 1 2 3 4 after 13, so which one be for which one, so that will be difficult. So that's why I'm just exporting that I already did, and then importing it here. If I add that plus sign, and then inside HEC-HMS, and then shape file, and which one is the one, that one I'm selecting, sub basin 1, right? So we just exported that one. So that is that. If I just turn off this one, and these are the sub basin we have. If I want to open that attribute table, can you see that we have this name sub basin 1 2 and 5, right? 6 8 10 11. See, the names are in different order, and the basin IDs are this, right? So we need this sub basin name. So we'll create the basin average precipitation and the time series based on that name, sub basin 1 2 3, and we'll follow the ID. Okay, and that's why we need that. So how can I do that? We have that option here. So the next thing I'm going to do, I'm going to create a CSV file. So click on arc map as before, because we need that CSV in order to use that in our script. I'll use the Python script to create time series, and I'll use that R script to create basin average precipitation. That's why we need that. So which one we have to click? Conversion, right? And then Excel, and then table to Excel. If I click on that, and now I'm going to select that sub basin 1, and then it will be like Excel file, and I can convert it to CSV. So it is gonna say there, okay, ArcGIS subbasin 1 E2 there. If I want to even change it to a different one, because we are working on HEC-HMS right now, so inside that HEC-HMS, if I put it that, okay, subbasin, okay, subbasin, then it will be like XLS, not a problem. It is, yeah, I think it's already done, or it's processing, maybe it's working on it. Okay, let me just check it if it is there. So it should be inside HEC-HMS, or where it is. HEC-HMS, there, it should be there. Maybe it's working on it, converting to, okay, it's, yeah, converting, and it's done. So you can see the message in the lower right corner. If I now go to that directory, see it's there, subbasin. So keep in mind, I think I don't need that here. I have to cut it, and I have to go back to that latest version, because I'm saving everything there. That is the previous version. So if I open it, see, and it will show that sequential order. So what do we have here? See, the field ID is 0 to 12, and the basin name is this one, and this one. So we have to even save this as CSV file. Then we can, okay, by the same name, I'm gonna use the same name and CSV comma delimited, and then save it. So I have the CSV file, because when I'll use that in my script or Python script, so I'll use that CSV. So the CSV, yeah, it's looking like that way. Okay, so I'm closing that one, and now if I go back to my HEC-HMS model, so now I have the subbasin, I have the watershed, the same watershed, right? The subbasin, I extracted this one, so I'll use this one. So let me quickly open my R script, and at the same time, what I'm gonna do here, I'm copying that. See, I have the NLS data that I already downloaded from 22nd of August 2017 to 10th of September 2017. I'm gonna extract that. Okay, so extract all, and then it will be extracted here, because I made the zip file, and then I'm just transferring from one computer to another one. That's why it is this. So we'll direct to that one. So let me, yeah, I think I also have that scripts, so I have to even, okay, copy those scripts as well. After doing that one, let me go to that script as well. Okay, so it's done, we have that. So I have these values, see, and these are, we already have idea about this one, right? I already plotted that one today in the previous tutorial. So let me just copy the script I have in my HEC-HMS. So these are the script I'm gonna use. That one is the Python script, and I have even R script. I'm gonna copy, and then I'll put it there. Okay, so there, I'll put it there, and here it is. Okay, so I have to create, I have the R, so I have to create a new project. If I open R, if it is already there, so it will show you the logo, right? The R Studio, the R Studio. If you click on that R Studio, because you can find the right how to install R Studio. It is not that difficult. So what I'm gonna do, I'm gonna even create, because it is opening the previous one, it's asking for installation. No, I'm gonna create new. Okay, go to file, and then new project and new directory. Then it will be easy for us to, a new directory, you can select that, and new project, and select that new directory, because we are doing for the first time. And here it is. Okay, inside our HEC-HMS, not HEC-HMS, let us take HEC-HMS, and here I'm directing that, and I'm specifying that basin average. Okay, basin average precept, and that is the R. So if I create the project, it will create another directory there, and it's there. Okay, so what I have to do now, I have to copy that script inside that basin average R, because that is the project, and I'm pasting it inside that one. If I open, so it will be directed to that one. So I'm opening this one. Okay, so now I have the script. So these are the default library that you have to install. It's pretty simple if you just install that way. So now it's asking to install. I'm gonna install that one. If there are some library that are missing, so it's gonna install. Okay, yeah, it's installing, and because I maybe updated that our version of this, that's why it is asking to even update that. So once it's done, let me just quickly explain that, and let me try to change the directory where I have that file. Okay, let me just copy that, going back where I have this. Okay, here I have all of this netcdf files. Okay, and okay, when it's done, because it's taking a while, not a problem, it can take a time because it is downloading and installing each of these packages. These are pretty important because we need to even see the raster. This raster will be used to read those netcdf file, and there will be gdal, right, or gdal that will be used to even project. For projection system we can use gdal or gdal, and we also have other libraries. Raster views means is the visualization. If you want to plot a raster, we can do that, and we need to have even HDF5 or that will read even that netcdf file. And because we are processing basin average, that's why we need different module there. And when we are done with installation, so what I'm gonna do here, I'm gonna, while it is installing, I'm gonna explain that. So these are the necessary libraries I'm just importing. So that is the command. In Python we use import, but in R we use library and then the name of the module. And here what I have to do, I have to set the directory where I have that files. Okay, so here I have that netcdf files. I'm just changing the backslash to the forward slash so that there won't be any problem. And that's that. Okay, so here it is, and now I have to specify where I wanna store that precipitation, basin average precipitation. So I'm gonna select the same directory, latest version here. However, I'll create one new directory there. I'm just going back, and here I'm gonna create one folder by this name because the name is there. So inside that folder I'll have that time series, the basin average precipitation, and then we'll calculate the time series from there. So file list, so from there it will list all these files. I'm specifying this directory where I have that files. It's pretty simple and straightforward. And now what it will do, it will just loop through each of these directories, and it will just read the base name, because the base name you can see if you focus on that file name, it is nothing but a big name, right? So it will exclude that part after that A. So that's why from starting to A, the index number is 19. So it will start from 207 and it will keep up to the time. Okay, we have the year, month and day, then we need the time as well. So that's why I'm just giving the name index, base name, and then I'm passing that as NCF name, my NC file name. So 19 to 31, it will give us that file name of the CSV file with like year, month, day, and the hour, right, in 24 hours, 0 to 23. And then what I'm gonna do right now, so when it's done, I'm just creating the date and time, and then I'm reading that file using that raster command. But in Python, if I import netcdf4, then we need this data set. But here we can use raster, and then if we pass the file name and if you pass the APCF, we know that, right? These are the variable name we selected this one while downloading the file. And then I'm printing the file name, and then just what I'm doing, I'm using that brick command to make it like a brick. It is called stacking. Okay, well, I'm just, because we have different layer, so I'm just stacking, and I'm just putting this as a brick. If you just pile a brick, so that is the thing, because it is a netcdf file, multi-dimensional file. So that is the command, and out of that one I'm extracting that, and here I'm reading the shape file. That is the command, read OGR. So that is the command to read shape file, and I'm passing where I have the shape file. Let me find that way where I have the shape file. I have to specify the location of the shape file based on which it will create that. So inside that HEC-HMS, right, and shape files, and the name of the shape file will be basin 1, okay, this one. So how can we extract? Go to properties and then security, and here copy the entire file name with its link, okay, let's say complete link. So there it will be like this. So I'm gonna change the slash from back to forward that way, and it will be pretty convenient to follow now right now, and there won't be any problem, I hope so. And see, so okay, what is that? Control G. Okay, so it will be like this way. Okay, so we are done with even all these directories, everything. So it will loop through that NC file, and it will read that APCP. It is in millimeter, and then it will stack everything, and then see, this is the command. It will extract this way. I'm giving the function mean, right, and it will do the job for us. So that is the basin average. I'm passing that shape file. See, we are passing that shape file because that is the command, that is the function extract. So if we pass that precipitation, I'm reading that after stacking that s.precip, and I'm passing that shape file. It will read and it will give us that precipitation, right? So here I have to specify the ID. So I have up to 13, so it will be 11 and then 12 and then 13, and I'm gonna replace the name, so following the same order. That is the thing, that's why I extracted this one, okay, because of this one I extracted the name. I have to follow the sequence, so I have to go back and then open that sub basin. Only because of this one I extracted that one, okay. So let me just put it there side by side, and okay, where it is. So these are the thing we have to do, right? That is that the first one, okay. The number 1 will be subbasin 1, and then we will have number 2 that will, okay, let me just put it that way side by side, then it's easy to even understand, okay. So that is the thing, you can even follow what I'm gonna do here. The first one is that, second one I'm just copying, okay, and there that will be okay. Control Z, I'm just giving the name 2, subbasin 2, and the next one is what? The next one is 5, subbasin 5, and then we have 6, okay. Then we have subbasin number 6, then it will be in a sequential order and it will be easy to follow, and then 6 to subbasin number 8, okay, basin number 8, and then it will be 10, and then it will be 11, because I didn't change the name, I'm working on different computer, that's why it's after 10 it will be 11, and then it will be 12, it will be 12, and then it will be 14, and then it will be 16, it will be 16, 14, 16, and then we need 17, 4, and 3. Okay, I'm copying this 3. We need 3 more watershed, and I'm pasting it there. So after 16, the next one will be 17, and then it has to be 4, and then the last one is nothing but 3. Okay, so we have the name in sequential order. Now what we can do, we can even run the code. It will store based on this subbasin, so it is in sequential order, and I think it's still installing the packages. It's pretty big. Okay, while installing this one, what we can do, so what we have to do, even we have to even download, right? Maybe it's done, or still no, it's red is there. See, what we have to do, we have to even download the observed stream flow, right? So we have this USGS station here, right? So if I wanna download the stream flow for all of these stations, right, for 15-minute interval, because we need that in order to validate our model even though we only use these 3 stations, right? So I'm gonna even show you how to download for all of these stations. So what I have to do, I have to create the CSV file of this list of the station, right? And the same thing I'm gonna do here. If I click there, table to Excel, that will be USGS stations, okay? And it's gonna save again there. No, I don't want to save there. I'm gonna save it outside of that HEC-HMS latest version, and here it will be USGS and then stations. I'm gonna create the list of the stations, right, for which I'll download, because previously what I already demonstrated, I put the list inside that code, but now I'm gonna show if I pass a list of CSV file, then what will happen. Okay, so that's why I'm doing this. So maybe it's see working there and it's done as usual, and see it's working. Okay, and then I can process that one. So I'll process simultaneously this one and that one. So USGS stations, I have to even create the CSV file. Okay, I don't need that. I need only this one, expanding. So see, these are the station number. Okay, so we have how many? 45. Let me just quickly convert it to CSV, and I'm putting it there by the same name, just changing the file type, CSV comma delimited. Okay, so now it's done. I have to upload this file to my Linux machine. Okay, I'm gonna run this one in my Linux machine, and then you'll see what I'm gonna do. So here it is, and I think you can run the same code in your Windows machine, not a problem. It is easy, but since I have access to that one and I can run it pretty quickly, so let me go to that directory where I have the script, and I'll upload that CSV file because I'm accessing remotely this time. That's why it is taking a while to log into my system. Okay, I'm accessing from my home to my university, so that's why it's taking a while. So CD, and then what I have to do, maybe it's inside. Okay, no, it's there. So what I have to do right now, it's there, and it should be by my name. Okay, yes, and then it should, yes, so it should be then again. It's working. See, it's accessing, it's taking a time. Okay, and then it will be like, okay, inside that NWM model. Okay, I'm just waiting a while. It's taking to create the list. Yeah, because of that network issue, maybe it's taking a while, not a problem, and that's why it's taking time to even install all of these packages that I need to process all this thing. I'm hoping that maybe it will take more time. Okay, I'm going inside the script, and I have the script there to download that 15-minute. Okay, so what I need to upload that file inside this one. I'm gonna upload that one here. Okay, so uploading that file from here. I think I have the CSV file there inside latest one, and then USGS station CSV. Okay, so I'm uploading there. So that is the station, and let me quickly open. See, download 15-minute USGS Harvey. Okay, I'm gonna use that for Harvey because that should specify that location. So I'm gonna specify the file name here. So previously I was passing the list as this way, but now I'm gonna pass that CSV file. Let me copy the name. It's there, right? USGS. Which one is that I just uploaded? It is USGS station name. So it should be inside USGS stations. That one. Okay, let me check it. And this one, okay, this one sends us into this one. Even if I can change the name as it is, so I have the same name by this one. It is the same file I have, so it is same one, so I can even use that one as well. Okay, so I'm copy that name. I'm copying the name and I'm pasting it, and I'm changing that input CSV file there, and now I have the CSV file, and I'm specifying the beginning date and the ending date. Okay, So now it will download the file where inside that, okay, USGS text Harvey station Houston, or I'm gonna change it to San Jacinto. Okay, Houston, okay, Houston San Jacinto there. So it will create one directory and it will create the text file for all of these 45 stations, right? So in order to do that, I have to activate my Python environment. Activate Python 3. This time I'm activating this. Okay, so now I'm gonna just run that code, right? So that will be download USGS. No, download Harvey. What is the name of the script? Let me check that. It is download 15-minute. Okay, so that will be download and 15-minute USGS, and it will be Harvey. Okay, so then it will start downloading the file that we are asking for. It is downloading. So let me go back and see the name of the file. It should be USGS text and Harvey. So it should be there, USGS. Where is, see, Houston and San Jacinto inside that one. So it's downloading. It's downloading. See, can you see that? Yeah, it's downloading. It's downloading, but there will be some files where there will be some missing data. So let me just show you. We have all of this 45, and you can see if I open that, see what it is gonna give us. So it is gonna give us this one, right? There is nothing. Okay, so here it is. This is for Harvey, and it is giving us the same name. We don't have this thing. See, we even can't get anything here. Maybe because I downloaded this one using the same script from my university and it was working. Maybe it is because of that server issue. Okay, let me find that USGS Harvey. Which one I ran, right? Harvey. I run the same one. Okay, if I go back to my that name. Okay, let me just check if the name or file types are same or not that I specified. So which one was that? San Jacinto USGS San Jacinto, right? This one, it was the previous one. I already, yeah, this one. Oh, I have to provide the name there is the, okay, this one should be the name, but I have to modify this one. Not a problem. I'm gonna use this name because I already modified that one. I was trying, but the script is, yeah, it is written that way. It will, see, that's why I'm asking. It is there. It is calling the ID from that column. Okay, so I'm saving this script. Definitely this time it will work. There is no doubt about it. And I'm gonna delete. I'm gonna delete that USGS San Jacinto Houston. Okay, where it is, that one. Okay, USGS San Jacinto Houston. Okay, I'm hitting that because I already saved that. If I hit it, it will start downloading the same file, and this time it will download definitely the file. So that's why it's taking time. So USGS, it should be not CSV, text file Houston San Jacinto, and it is replacing everything. See, when it will be done, then we can see that because it's replacing. I'm just waiting for this one. Let me check if it's done or not. Still it is downloading and still it is installing. Okay, so it is not a problem. We have to maybe wait, or we can process by this time this stream flow, and by this time I think it will be done, and then we can use that one as well. Not a problem. That's why I'm just doing the 2 or 3 separate processes at the same time because of that issue. So I think it's already still downloading. Then we'll use even another script. So we're done, and we can see, if I see, but that's why I have to check before processing our text file. We have to check because we don't have, see, you can see the file size. We don't have so we have different name there, so it's creating problem again. I'm gonna delete the entire folder because it creates double file, the previous one and the newest one, right? So that's why what I have to do, it's deleting, and I have to run it again. So these are the processing you have to keep in mind. And this time I can check, I can show that what it is actually doing, because all these stations, it doesn't have that precipitation data. So we have missing data as well. See, for example, the first one, if I open that, there is nothing, it is empty, the data is missing. So we have to remove that before running our next script. So the next one, see, it has 201 kilobytes, so it has data. And for other stations, even you can see we have this data 15-minute interval. Can you see that? Yeah, we have 15-minute interval from 22nd of August to 10th of 11th of September. We have that, not 11th of September, even it's 11th of October. I think I don't need that huge data set. I mistakenly maybe have written this one. So what we need this to be 09 September. Okay, then it will be easy. Let me just quickly refresh that one. It's done. Let me quickly run it again, so that what I'm gonna do, because I processed it one for Delft 3D model, that's why the date is different. The date is different. I'm deleting that again, and if you run it, it will take a while. Okay, not a problem. So I'm using different scripts, so that's why before running that script you have to check and see it's pretty quick. And this time maybe we'll have more station that have missing data. So where is the, it's almost done. See, yeah, so we'll delete those stations where we don't have the data. And this time, see, it's from 22nd of August 00, and then the date should be, see, September 11 and 23rd 45 hour. So now we'll run another script, but before doing that we'll check which stations are which station has missing data. The stations with 1, see, the size is 1, these are the missing stations. So we're gonna select all of these stations that is with 1 size, 1 kilobyte. So I'm gonna delete, otherwise the next code it won't run, because it won't find that condition that I'm gonna give to create that time series. So that is the pre-processing we have to keep in mind. If you wanna use code, we can do that. So I selected all of this missing stations which have missing data. So now every stations we have the data. If I click any of them, let me show, yeah, we have the data. Okay, so let me run my next script to create the time series. These are the text file I just downloaded, and now I'll have another script here. Can you see that? So USGS 15-minute text to CSV time series maker. So that will give us that. Okay, USGS convert 15-minute text to time. So both way it will work. So I'm gonna even use that one. Okay, if I open this one, I have to change the directory where I saved my file. So I can remember that I have the file here, I just downloaded. So I have to give the input directory, it is there, and I'm gonna save that by the same name, but I'm gonna change it to CSV. Okay, so it will read everything from this file. The text file is there, right? The text files are there, and it will create CSV files inside this directory. Since this directory it doesn't exist, so it will create a new one, and then it will go through all this step. I already mentioned that one in my previous videos, where I already demonstrated how to download. I already demonstrated everything, right? The condition I specified there. So I'm gonna run this script to create. So that's why if you have a script for every condition, then it's pretty easy to even follow, right? So otherwise it takes a lot of time to test that script, and it took a lot of time to even do this. But now it's life is easy, right? And at the same time, see what it's gonna do. Oh, it is gonna even plot. Okay, so let me just kill it, because it will take a lot of time. I'm gonna use the other script I have. It won't plot, but it will that one convert. Okay, if I use that one, it will even, that's why I change it to this. Okay, I can change these 2 lines there, then it will be easy. Otherwise it is gonna take a lot of time to plot, because we don't need to plot. Okay, so USGS convert. Okay, Python USGS and then convert. Okay, then it will take less time. See, it's pretty fast, right? Fast. And if I wanna show you that what it is actually doing, otherwise it should take like half an hour. So we don't have that time, right? So we have this CSV there. This CSV is basically the time series this time. See, these are the time series, and in CFS, and if I plot it, you'll see that this is the time series, right? We can quickly see one of them. So we have this time series. So from the text file, we don't need to even download the text file and import it using the data and text legacy, everything. We don't need that. I just avoided everything, the hassle we had. That's why whenever I think, okay, I need to even do the repetitive tasks, I write the script, and this is the benefit. So see, if I even check, we need only 3, right? We need only 3 stations. These are the stations, and let me check if we have actually the time series we need. It is a 3500 and 4610 and 6700. Let me check if because we have many stations, we downloaded everything. It is another step to show you how to do that. So we don't need this one. So I think it is a 700-0807300, right? So far I can remember it is that one. Okay, so that is the station we need. This one, select that one, and we don't have that station. We deleted 6. Okay, 4610. So we have another one, 76700. Okay, the last one, 076700. So that one. Okay, so we have only valid data for 2 stations. I'm gonna download these stations and I'm putting it inside my directory where I'm saving everything, and then we'll add that station in our HEC-HMS model. Okay, so here it is inside that latest version, and I'm gonna save that. And let me open, yeah, while saving it, I think by this time it's done. Let me check that if these are there. Yeah, see, these are the stations I downloaded. So let me check. The first one we have, right, 770, both are same, or that should be 3500. I mistakenly downloaded this one. This should be deleted. It's not that one what I need. I need basically 73500. This one, right? 080735 08, okay, 073500. So that one I'm gonna download it again, and I'm putting it there. I think it's done pretty quickly. Let me open that. These 2 files we have, okay, 35 and 67. So we already checked that. We have the data for this one. Let me check if we have this data for this entire period. Yeah, we have this data not from 22nd of August 2017. We have 25th of August and all the way to, maybe let me check that, but these data are we have data up to 1st of September, right? But maybe these data are not even uniform. Maybe we have missing data. So these are the 15-minute data. Okay, 15 minute up to this date. Okay, not a problem. What we can do now, we can even import. Let me check the R. Still it is installing and downloading everything. Even I didn't run that, so it's just installing everything. Okay, I don't want to do that right now. It's installing. Okay, if I save that, it will just start from the beginning. I don't want that. Okay, so what I'm gonna do, I'm gonna open. These are the steps I'm showing that on record so that you can see what we need to even need to do all this processing we need. So what I'm gonna do right now, I'm gonna add by this time these 2 observer stations. So we have 1 observer station here. We have one, but we don't have observed data there. So we'll have another one there. Okay, so what I have to do, I have to go to that component and then time series data manager. This time I'll add, when my precipitation will be done, I will add the precipitation. We'll have 13 different precipitation time series, but this time I'm going to add discharge gauges. Okay, and new. So this will be the name of our stations. Okay, for simplicity, I'm gonna right click and then rename and copy the number so that I can even put it there as the name of our station. Okay, these are the discharge station. I'm creating that one, it's done. And if I create another one, I have to go back to the directory and I'm gonna copy the other name so that it will be the same. Okay, this is how I create and then create. So we have two different empty time series. Okay, so here time series and then discharge gauges. These are the gauges we have. So what we have to specify, we have the data range from 22nd, right, August 2017 and 00 up to, let me check the data for this one. Maybe we have data up to 11, right, 11 September 2017, and it is basically to 2345, and then it will create the table. But see, it is meter cube per second, means CMS, but our data is in CFS. So what I have to do, you have to select first, click on the number and then manual entry, cubic meter per second. No, it's cubic feet per second, and the data interval is 15 minutes. Then create this date, and now we'll have the table. See, the date is 15 minutes. And what I'm gonna do right now, I'm gonna even go to that directory, open that, copy the values and paste it. Okay, so we have the data from August 22, 00 hour to all the way to September 11 and 23:45. I copied. Okay, I'm just copying this one, Control C, and then I'm opening that and I'm pasting it there. Okay, Control V. So it's there, see, and you have to check, right? It's there. We have to check 11:45. Okay, these are the data we can see, and then even we don't need that because we have some missing data. But if I click on graph, you will see the graph, it is showing there. Okay, so in order to be on the safe side, what I'm gonna do, I'm gonna even use the same value for this one, or this will be like, we have some missing data. See, if you go next, so we have some missing data there. It is not even 11, this one, maybe we have some missing data in between that. Okay, in between our different date, maybe these are not continuous. During this Hurricane Harvey, the measurement was disrupted, so that's why they may not be able to even measure, right, at every 15 minutes. So these are the demerit, we have to focus on that one. Okay, so what do we have to do, we have to even, okay, run the model less than that time. And if I, so it is gonna be up to 11 September 12 hour. Okay, 11 September 12 hour. It is not going to, okay, let me select to 11:45. Let me specify the date, 11 September 11:45. Then the problem will be solved. Table is okay, the graph is okay. So this is how otherwise the model won't run. Okay, so now we have this data for this one. So what about this one? Okay, this data, so it has to be the same, feet per second, 15 minute, manual entry, then change the date. It is up to from 5th of August 2017, not from 22nd. That's why we have to even specify. But here maybe we'll have less time. Let me check it. So this will be 1st of September 2017, and let me check the data. Here it is. Okay, and once it's done, it's from 2015. So the time is 2015. We have to check everything so that it is synchronizing. 2015 and 1st of September. Okay, 2015. I'm gonna copy it all the way to September 1, 21st 30. Specify that 21st 30, and then it will create the table. I already copied, right? Let me check it. Control C, and I'm gonna paste it there. Click there and Control V. Maybe it is not even covering the entire thing, so let me just cut it there because we have some missing value in between our date and time. It's covering up to 20 August 1915. So this is how we have to change. Okay, 28th August 1915. So in order to do that, 29th August, 29 August 15. Okay, let me check that again. 1915. Okay, 1915. On 19, this should be 15. Then I think our table will be filled up. We can check the graph. Maybe the table is okay this time. Is it okay still? 25th of August 20, and then maybe it's not. Let me check it again. Why? Okay, let me paste it again. Control V, because I'm pasting that. Still it is not done. So why it's not done? 28th August 1915. The table should be up to this. Okay, time 25th August 2015. Okay, this should be 28. That's why it was not working. And this should be 1915. This time the table should be filled up. Okay, now we have the graph like this. Okay, so this is how we have to specify the problem that we have. Let me check by this time. So what we have added, right? We have added this discharge. So where it is located, let me zoom in. It should be there, right? Where? Or let me turn off that layer, that terrain layer, so that it is pretty easily visible right now. Okay, so that is good. Okay, so then we can even zoom in quickly. That should be which one? The junction. If you click, it is junction number 8, and go to option, and at 8, what is the observed flow? It is that one, 3500, right? We have another observation. This is how we can add observation. We don't have anything, so we have another one. This may be 7. Go to option, so the next one is there. So when we'll run the model, then it will automatically compare the simulation with the observation. So this is why we are adding this one. Okay, I'm saving this one. Let me check if we maybe it's already downloaded. See, we're done with that one. The packages are done. So now, okay, let me run that our script to calculate the basin average. Okay, so if I run it, hopefully it is gonna, yeah, it's gonna be creating everything. Yeah, it's error in library raster views. We don't have that library. Why? So install packages, install package, and if you provide the name it is asking, okay, this one, then it will install. Provide the name, it should install. Okay, okay, so it'll be like inside that comma, inverted comma. Okay, this one and this one we have to provide it as, otherwise not a problem. Will, yeah, it's not available, maybe it's looking for that one. So raster views, okay, we don't need that one. I'm just turning it off and saving it because we don't need all of this. Maybe this time it is gonna run, or let's see. Yeah, it's working this time. See, it's creating the basin average, and let me show you what it is generating there. See, it is generating this file, see, pretty quickly, right? It's pretty amazing. And now it's working inside that folder file, CSV file. See, these files are basically based on their year, right, month, day, and the time. See, it is in sequential order. So I'll use another code to create time series for each of this basin. So here it is. What it is giving? It is giving us the values of the precipitation. Basically, these are the sub basin, right? That's why I created this name. And I'll create the time series for this sub basin, for each of this sub basin by this name. Then we'll create the, okay, so we have to even remember this name, the same name, 1 2 5 6, okay, to create our gauge. It should be 1 2 5 6 8 10. Okay, let me create the gauge by this time, then we'll add that. So these are the sequential order you have to follow to remember. Okay, you have to follow this protocol. Okay, now I'm gonna go to precipitation. Okay, what you can do, since we already have the date and time, So okay, we can even, okay, we can, what we can do, we can copy, okay, right click and copy. So that will be case 1, means for subbasin 1, and if you create copy, it will copy everything. So what we have, we need 1 2, right? Let me check it again. We need to do 1 2 5 6. This will be our name, or 1 2 3 4. Oh, 1 2 3 4 5 6, or we don't have 7. Okay, so 1 2 3 4 5 6 8. Let me show you. So we have 1, so now we'll have 2. Okay, then we have gauge number 2, and from gauge number 2, if I create another copy, so we have to have gauge number 3. So this will be for subbasin 3. That's why I'm creating the same name or number as we have the number for our subbasin. So that will be 4. Then this is how we have to create 5 up to 13, and then we'll add our precipitation when it's done. So these are the process you need to know. This is 5, 1 2 3 4 5 6, and then 8, right? Okay, so then it will be like 6. Then copy and paste, so it will copy the time. You don't need to even create the time again. So this is the benefit we have, 8, and then I can remember that the next one will be 10. So the 10 means it is corresponding to subbasin number 10. So when we'll add that, we'll add pretty easily. So what is the next number after 10? So after 10 is 11 12 14 16 17. Okay, 11 12 14. We don't have 13 and 15. 11 12 14 16. So the next one is 11. We already have, we have to, yeah, we have 10, so that one is 11. And then the next one will be 12. Next one is 12. This is corresponding to 12, gauge number 12. And the next one will be 14 instead of 13. Okay, so these are the necessary steps we have to do. So we have 14, then we don't have 15, so we have 16, right? The number, I didn't even change that. That's why I'm just doing the same way we have, because we merged them together and we don't have that. So we have 17. Now how many gauges we have? See, 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, so we'll add the precipitation for subbasin number 1 here, and that will be for 10, that will be for 11, and then I'll add them together. How can we do that? Still, since we already have the meteorological model there, right? So here, specify there, we can even add. Now we can add, and we can add our gauge number. We already have our gauge number right now, so it doesn't matter. So for subbasin number 1, we just match that, it is 1. For 10, check the 10. For 11, check it as 11. For 12, it will be 12. This is what I did, right? For 14, select 14. For 16, it will be corresponding to 16. And for 17, it will be 17. And for 2, it is corresponding to subbasin number 2. And for 3, where is 3? There. And for 4, it is also 4. And for 5, so this is pretty easy, right? So that's why you have to follow some algorithm. And then experience says that. And then 8, it is 8. Okay, so now I have linked every basin with every gauge we have. Okay, I'm done with everything. I'm saving the project. Now I need to even add the value of the precipitation because it's empty. Okay, because I copied still what I have, because I copied that thing, that's why it copied even the values as well. Okay, so I have to replace these values. But if you run the model, definitely it will run, not a problem. It will run. What I did, if I can run it, RV run, definitely it will run. Okay, see, it's running because I have the values of the precipitation. Whether it is right or wrong, doesn't matter. It assumes that, okay, we have the values, and see the thing, I can even show you that at junction number 8, right? So if I go to result and junction number 8, you see we have the comparison between observed and simulated. So the simulation is so high compared to observation, right? Compared to observation. That's why, because our precipitation is same, but in reality it is not like that. So if I calculate that one, that's why I just showed you how to run the model yesterday in the previous tutorial, right? See, let me check that if it's still working. Okay, it's still working and it's generating that because we have more than 400 files. See, so let me prepare my Python script by this time so that we can even work on that. So that will be pretty easy. Let me check if I have spider. Okay, I have the spider app. I can run that. Maybe it's not there. Maybe I remove that. Do I have that anaconda installed? I don't know. Maybe. Okay, let me figure it out. Otherwise I'll run this in my Linux machine. Jupyter notebook. Let me check. It's not there because I uninstalled that conda. So what I have to do, not a problem, I'll run this in my Linux machine to create the time series, and then I'll download that again. So let me quickly go back, and okay, here I'll create that time series, and then I'm gonna upload the script I have. I'll upload that one and I'll run it. You can run the same script wherever you want. So upload, I have the script there, NL loss. Okay, the other one, Python NL loss time series from basin average data. So if I open it, it's gonna, okay, wait, so do I have it there or inside my script? It should be there. Okay, let me check it. NL loss, where is N? Where is NL loss? It should be there. And okay, NL loss time series basin average. Okay, there it. Let me open it, and you'll see what we need. It is nothing but this one. Let me check the file. It should be up to 11, and then we'll specify that directory. Let me copy and create one directory there. I'll put the precipitation value there. I have to create one new directory. So which one? Okay, that one will create new directory here. Okay, and I'll upload the file inside this one. So that's why, since it is a Linux machine, I have to use this command instead of full directory, but I have to provide the full name. So it will read everything from there, and it will create the time series. We need to even read that subbasin that I already passed. It should be the same subbasin, the CSV file I mentioned, right? So let me open that. The CSV file I already converted from chef file to CSV files. So let me go back to that one in two different windows so that we can check it quickly. Latest one, and which one is the subbasin? That one. Okay, so this CSV file contains that list of the subbasin. This one, okay, in the same sequential order. So I have to upload this one there. Okay, this one inside my script subbasin. Maybe let me check if we already have that. I tested it. Okay, let me upload that one this way, and okay, maybe it's there, subbasin. Okay, subbasin CSV. I'm uploading that. Everything is okay. We only have to upload our, and it will create the time series by this name, input, and then it will create the output directory. Here we have to specify the output directory as well. So it will be okay, HEC-HMS, one directory up. Okay, HEC-HMS time series. If it doesn't exist, so it will create one as usual, and then it will do the job for us. Not a problem, it will do pretty quickly. Okay, so I'm done here. I'm just waiting for this process. Okay, we are done with that one. So it is done up to that one. It is not even creating the last file. So 700 in September 700. So the last file we can delete, and we can take September 6. Okay, so I'm deleting the last file. I'm uploading up to September 6th and 23rd. So the date is up to September 7. Okay, we are okay. So what I have to do, I have to upload the files there. Okay, just I'm going back one directory to basin average precipitation so that I can upload those files and I can run. So it will pretty quickly. It won't take that much time. It is so fast, so it will take only that time to upload. Okay, I'm just Control A and it's selected and opening, so it will upload everything there. This file's 384 file, it won't take that much time. Maybe here it's gonna take a while, but no, it's not gonna take that much time. It's pretty fast because these files are pretty small, right, in size. And then we'll have our time series from that basin average. So these are the processing. You have to follow a specific protocol steps, right, so that we can even optimize your time. See, at the same time I'm working on downloading this one and doing that one, so I'm running that code. And okay, did I save it? Let me check that. Okay, no, I didn't save that, so let me save that. Then everything is same and it's okay. So nl thus nl, let me, okay, it's there. So if I click it from basin average precipitation, it will run. If everything is okay, directory is okay, it will quickly see it's reading, and it's reading every file for each of this one. Then it will create the, it's creating the time series. Okay, so it is what is the name of the output file? It is HEC-HMS, right? Where is that? HEC-HMS. It will, and HEC plus HMS time series. See, it is creating everything there. It's already done. Subbasin 1. So we have these values. See, it's pretty convenient, right? So if I plot that, we can see we have 0, and these are in millimeter. If I plot it, you will see, you'll see that it is pretty good. I'm showing only 1 so that you can understand what it is actually going or giving us. Okay, it is giving us this time series. So that is exactly what we have here, right? These are the hourly data. So there, so the peak is 35 millimeter. It's so huge, and the daily value is more than 500 millimeter. So we are done with this one. So what I'm gonna do, I'm gonna save this file because I just processed it, everything. So these are the steps you can do. You can just go forward and backward, but we can even do the same thing. It's taking a while to, okay, since it is plus, let me just rename it because it is, oh no, it's okay, HEC-HMS, and that's, oh, that's okay. Let me download that and it will put everything there in my latest version. So it's pretty even quick. 13 file we have, and we have this data. So from this basin average, we have that HEC-HMS time series, the first one. Okay, first one. So what I have to do, I have to even change the time. Okay, the time is okay, let me go to component, the basin, I'm removing that one. Okay, so I'm going one by one. So guess one, that time from 22nd to, that should be 6th of September. Okay, 6th of September, and that should be 23. So these are the thing I have to even modify. And table will be up to this one. So now I'll open one by one and copy and paste. Subbasin 1, it will be for 1. Okay, I'm just copying. Okay, wait. So I'm just copying and I'm pasting. When I'll be done, so I'll run it and then I'll stop this tutorial. Then in the next time, in the next segment or next part, I'll even estimate the model parameter. I'm pasting it there. Okay, I'm pasting it there. So I think it's covering the entire time, and let me plot it. So it is like that if you want to plot. And the second one is 10. I'm following from the beginning, so it is the same 06. Okay, it is same 06 and 23. We have up to 23 because we're gonna, this time we'll run the model from 22nd to 23 because we don't have data, because we don't need up to September 10th. Okay, so it is for 10. The next one is for basin number 10. Where is 10? There is 10. Follow this way. Okay, so now I'm gonna copy for 10, Control C, and these are the manual step you have to do. And now it is Control V, right? So everything is in millimeter. You can see the plot is as it is. The second one is for 11. Okay, change this. I should have changed that previously, but I copied that, the same one. Okay, not a problem. So the second one is 11. Keep that in mind. I'm gonna close this too. I'm not gonna save that. So this one is for 11. Where is 11? This one is 11. Okay, this will take a while, not that too much time, only within few minutes I'm done. So these are the steps I have to do. Control V, I'm done. I'm seeing the plot is time, and then it will be 12, and it would be faster if we just selected the accurate time because the data is not completed. That's why maybe it's showing that way. So now it's 12. Okay, the next one is 12 and it will open, and then I'm just Control C and Control V. So these are the matter I have to do, and I can see it's time I'm creating. And now we have 14, and then it's 06, and then it will be up to 23, and then select the table. It is 14. Keep that in mind, that is 14. And then I'm waiting for opening, so Control C, and 14 is done. Control V, I can see that plot. See, this is the Harvey, and now it's 16. Changing the time, 06, and it will be up to 23, and that is the table. That is 16. Okay, 16. So here it is. See, still it's taking a while, but this new model, the method is pretty fast, and after all this thing, still it is taking a lot of time to even set up this model. And then the next thing will be like parameter estimation. That will even take a lot of time because we'll estimate our curve number, because I need to even use the curve number as loss method. That is the most convenient method. I'll show you how to do that from soil map, because we ultimately need to do that. So this is 17. Okay, 17, and then we'll go back to our lower number, 17, because I already added that gauge to our sub-basin, so that won't take any time. It is only taking time to even fill this off. Okay, so that is done. Then we have to go to 2, gauge number 2, it is 6, and then that will be 23, the table. And I'm just closing that one pretty quickly so that you can even remember that what is happening. I'm refreshing this, closing. Okay, I'm done. So now it's 2, right? So 2, I have only few. It's even, these are the laborious tasks we have to do. See, I used different programming, right, code, and after all this thing, and I have already demonstrated in my previous videos, it is already there, how to create basin average using GIS. So I already demonstrated that one, so I'm not gonna show you the same thing. You can watch that video. I uploaded that one, I think, more than 1 year ago. So in details, it will show you that, okay, this is the step to create model builder, and it will do the same data for the same data NLDOS, and then you can understand the 2 steps. That's why I'm selecting, or I'm calculating this time using my Python and MATLAB and R code. So I know R programming, I have knowledge on Python, MATLAB, so that's why whenever I need, I can quickly jump on that, and then I can use that code to make it easy. Okay, so you have to do that. If you increase your knowledge on different programming language, then it will be easy for you to even move faster. So now we're gonna finish that up to 4, right? So we're on 4. Let me open gauge number 4 for sub-basin 4. So this is how I'm following the specific step, because I created that one, so that I'm just optimizing the time. Now I'm on 5, it will be 06. If you know the shortcut, then you don't have to do the manual job. Okay, so this is for 5. Go to this one, 5. I think we have only 1 or 2 remaining, so I'm copying and I'm pasting it there. Okay, so that is for 5. We have 6 and we have 8, 6 and 20, 23, open 6, and I think we are almost done. Then we'll run the model, and then we'll finish the video, and I'll show the result. But this time you'll see there will be some similarity in between observation and the simulation. Okay, but previously we used totally abrupt values, that's why it was that huge difference right? But in reality it won't be like that, but still there won't be 100% matching in between observation and simulation, but that's where calibration comes in. We have to calibrate our model. So the last one I'm gonna do, so right, while even see I even didn't use any impervious layer, I use only 0, but since it is Houston city, it is basically most of the area is pervious. So when it is pervious, there will be 100% runoff, there won't be any loss, but I'm assuming okay there is no impervious layer, but in reality it will be this. Okay, so we have to even correct that one. I'll calculate from soil map and land use information how to calculate that curve number or percentage imperviousness. I'll show that in the next video hopefully. Okay, so I'm done with everything, literally everything, and I already have done with, see, I already added this one, the corresponding gauge one for sub-basin 1. That's why I was trying to match the name. Okay, 10 is for 10, 11 is for 11. You can check that quickly. 14 for 14, and 8, 6, 5. Everything is matching right now. So everything is ready. So our forcing is ready, but still we even change the model parameter, right? The method we selected, like the parameter is selected for canopy. Canopy is, it's okay, and loss method. Basically, we have to even select these values. We may have to change these values, right? Still, we need to change this one. So we'll work on that. Not a problem. We'll estimate that one in the next part, and we even have to change the masking gum. Yeah, we have to estimate the masking gum values, because you have to know the X value. We know that is from 0 to 0.5. We can use the average value 0.25, but what about the masking gum K, the time? We have to estimate that one. Okay, we'll use that. So now I'm keeping that as it is. I just added the basin average and the observation data. Now I'm saving that, and I'm going to run the model again. If everything is good, it will run. Yeah, it's running, hopefully. That's why we're lucky. Yeah, see, the simulation is done. It's so fast. That's why people are using this software. But if you run the model for, I ran the model for 25 years, and it was a bigger watershed than this one, and it was taking like half an hour for 25 years of run. Okay, that's why people are using that hydrologic model to generate rainfall runoff. And if I wanna show you the result as before, 8 is here, right? We have observation, and it will show you the comparison. See, so still we have one peak there, and the simulation is there, and our observation is this way. So we have to fix that. And then what we have another one at 7, right? So what is the name of this? It is junction 7. So find junction 7, and let's see the comparison, that one. So here, see, it is missing the peak time, but still the observation is so high. Can you see that? Yeah, it is 120. So we even didn't use any imperviousness, right? Definitely we have to do that, because it is Houston city. It is Houston city, you know that, right? It is very big city. So let me quickly change that, and then I'll show you, because this is the thing I have to estimate. But it is nothing but Clark. It is a loss method. There it will be this one. See, it is even 0. So what I'm gonna do, I'm gonna use even at some places it will be 100% or 60%, 70%. So I'm gonna do even it is a 40%. Okay, I'm gonna select 40% for each of the sub-watershed. Sometime it will be more than that, but for the sake of running this model, I'm just using the same value for everyone, 40%. And let me run it again, and let's see if there is any change. Definitely there will be huge change. So I know which one is more sensitive, because I already have experience on that. See, now it's this one. It's increasing a little bit. Previously it was lower than that. So if we even change other parameter, it will increase, right? It will increase the values. And what about that one, result, and 8, this one, this time definitely it is also changing. Okay, so the thing is, here we have overestimation there, and here we have underestimation, right? But what about the outlet at the sink? That is the accumulation of everything. See, that is huge. So we have two different peaks. One is there, and another is there, right? On September, at the end of August, and it started on like August 27 or 28. So it is like close to 3,000. So 3,000 CFS. It's pretty huge, like 100,000 CMS, and flowing to the Galveston Bay, right? Here it is, the Galveston Bay. This is the city, and that is the Galveston Bay, and it's flowing. So here it is flowing. The flow location is here. See, that is the huge lake. So all this water from the city, because this city is basically what? It is impervious, right? It's a very big city within Texas, and it is a renowned city. Most of the high officials are there, and big companies are there, and then it is flowing towards, right, this way, and it is flowing to the Gulf of Mexico at the end, right? If I show you that one. So that's that. We started our GIS tutorial, and we are just following this one up to the generation of HEC-HMS model, and then I'll select one big stream to even set up HEC-RAS model. Okay, and then we'll be done with this one. So that's that. I think we are good. We are on schedule, right schedule and right time. Everything is working so well. That's what I was thinking, but I was thinking maybe it will take a lot of time, maybe my code won't work, but everything is working properly. The plan I made, I'm happy with that one. So you can try what I just mentioned. If you try hard and if you try to learn new thing, definitely when your model will run, and then definitely you'll remember me that your feeling will be really good. If you set up a model and then if it runs, definitely you'll get the amusement. If you will enjoy the pleasure of running any model. If your code runs, then that is another another pleasure we can feel, right? It only understand or feels the programmer if you run any code and if it runs. So that's that. I'm not gonna even extend the video anymore. So that is the third part. If you haven't watched the previous part, you can go back and you can see I already demonstrated how to download and install, and I created the model, HEC-HMS model from the DEM. This is the latest version, and the benefit of latest version is that you don't need to even import the shape file that we did previously in the previous version like 4.3 or 4.4, but this one we don't need that. And after finishing this tutorial on HEC-HMS, I'll even create another HEC-HMS tutorial on gridded model, because this is the lumped model I'm using, and in the other tutorial series I'll even create the gridded model. I'll use standard hydrologic grid, and I'll show you how to create the gridded precipitation. If your model is gridded, then you have to create the gridded precipitation, and I'll also use that time. I'll run the model for a long time, like for 20 or 30 years or 25 years. Then I'll even use a different loss method, soil moisture accounting method. Okay, and then I'll show you how to estimate those parameters, and then I'll even, for that SMA we need like temperature, I'll use a Penman mounted precipitation. So I'll even calculate I'll show you how to calculate that relative humidity, because it needs that relative humidity, pressure, temperature, and short wave radiation, long wave radiation, everything I'll show you. I already downloaded these variables. That's why when I was downloading this netcd file from NLDAS, I selected everything. We have every variables there, so our data is already available. We have the data, so we can even process that one when I'll run that one. Okay, so that's that. So I'm gonna finish up here. Thank you very much for watching this video, and you can practice and let me know if there is any problem. You will get problem only if you try. Otherwise, if you see someone is doing and it is looking like very smooth, but if you are gonna do it, definitely you will face different types of problems. So that is the reality. You have to understand that. So practice this thing. These are the hands-on training. Unless you practice, you won't learn anything. Okay, so thank you for watching, and stay safe, and see you in the next tutorial. Until then, goodbye.